With those examples in mind, we're ready to update our interpreter. Here is the old case for identifiers in the interpreter. We just looked up the variable in the environment and we got a value back. But now we don't get a value back anymore. Lookup has to change to give us a location because the environment maps variables to locations, or maps symbols to locations for variables. So we need to use our store lookup function, the fetch function, to take that address and then get the actual value out. So again, the ID case, we look it up in the environment to get a location, and then look in the location to get the current value from the store. On the let case, this is what we used to do. We used to interpret the right-hand side to get a value, and then we extended the environment to map the name to the value. But we can't do that anymore. We can't put the value in the environment. We have to put a location. So we're going to put some location L in the environment. And in the store, we need to map that location to the value that we get from the right-hand side. And that only leaves the question of where does L come from. L should be a new location, so we will use our new loc function to allocate a new address and use that for the new variable, both in the environment and updating the store to have its value. Let's look at the set form. Set has a variable and a value. We will need to interp the value expression, but var here, that's not an arbitrary expression. When you do setbang, you have to say a specific variable. It can't be an expression that computes a variable. So that's why we don't have an interp around var. It's already just a name represented as a symbol. After we interpret the value expression to get an actual value back, we want to change the meaning of var to be that value. And the way we change the meaning of var is that var corresponds to some location in the store, and we can get that location using lookup. So when we look up var in the environment, it tells us the location where the value of this variable is stored. We will get some value back from interp. That's the VV, so we want to change the store so that L maps to VV instead of whatever it currently maps to. So we will have an override store of cell VV, extending the current store, or the current store after evaluating value. That gives us the updated store, and then we've decided, let's decide that setbang for curly returns the new value, just like we decided for setbox and curly. So we need to pair this store with the value, and we'll just use VV as that value. The rest of our interpreter can stay the same except for one case. There's one other place where we're creating variables. That's when we do a function call. When we do a function call, we get the function value, we get the argument value, we eventually interpret the function's body, and we were extending the environment to map the function argument name to the argument value. And this is the part that doesn't work anymore. We don't bind names to values, we bind them to addresses. And so we need to do a similar thing that we did for let. We're going to change the binding to be binding the name to a new address, which we allocate with new loc, and then we override the store to map that new location to the value of the argument. So let and application again look pretty similar, where they both have to allocate a new location for the variable. You can check the full code on the web page to see all the pieces put together.